The challenge for the Team 6. What is the challenge? Was basically to make an autonomous puzzle bot that could navigate through a mapped environment, localize and reach certain goals, and avoid collisions with static and dynamic objects. Kalman filter is basically a recursive algorithm that estimates the state of a system by combining a motion prediction model and sensor measurements. It tries to minimize and reduce the uncertainty, the error of at every step that it takes. The diagram for the extended Kalman filter we used is basically propagate the puzzlebot state using an arc motion model. Then it gets feedback from the Monte Carlo localization algorithm, and it filters it to reduce the covariance of the error that it's calculated. We choose Monte Carlo localization over Aruco because Aruco requires visible markers. If it's not visible for the robot, it could lose itself, and also if the markers are displaced and or are changed from positions, then you have to readjust and recalculate some measurements in the real data. And Monte Carlo only requires the static map and the LiDAR data instead of some static transforms. The odometry node we use for the Kalman, it's a dead reckoning system in which we measure the encoder noise and the encoder measurements for linear and angular velocity to calculate the state, so we can measure the uncertainty propagation for the Kalman filter.
So we have Monte Carlo algorithm that we use a distance transform in case of racecasting for a better performance. Also, we have the motion update that we propagate n numbers of particles in all the map, and we reduce it when the robot starts moving. And we have an adaptive dual mode globalization that we have a global mode that in this case propagates the particles in all the map, and a tracking mode that reduces the number of particles for a better performance and reduce the computational cost. We have 4-layer navigation pipelines. That is the coast map node, the RRTT global planner, and the pursuit follower. Also, we add a DWA node for local path and the avoidance of objects. Here we can see the 4-layer navigation pipeline. And some problems that we encounter. We have two main problems that we encounter. That was the RRP leader mounted. We have rotated, and how we find a solution. We modify this some parts in software that in this case was the URTF, and also we have the robot can localize while stationary. So what was our solution? We start moving the robot in short time, and also given threshold of distance, so the robot can localize. And this is our complete node path. And here you can see our video.